Hello everyone, welcome to this session on the t distribution. So what is t distribution? It says here that the t distribution is also known as the student's t distribution. So this is another name for t distribution, and it is a probability distribution that is used to estimate population parameters when the sample size is small. So when the sample size is less than 30, we use t distribution, and or when the population variance is unknown, or we do not have knowledge about the characteristic of the population. So this t distribution was developed in 1908 by William Gusey. So William used the pen name student when he published his paper, which he describes this distribution. That is why this is called the student's t distribution, because student was the pen name that William Gusey used. So he used to work at a brewery and was interested in the problems of small samples, for example, the chemical properties of barley. And in this problem, he analyzed the sample size might be as low as 3. So that is the history of the t distribution. Let us proceed with the properties of the t distribution. And to start with, we have number 1. The t distribution is symmetrical about 0. So if we have here a t curve, we can see that if we draw a line along 0, along this part of this curve, we will result with the two identical parts. So when we talk about the area of these two parts, the area of this right part is equal to the area of this second part. And it looks like the right is the mirror of the left, or mirror image of the left, and vice versa. The next property of the t distribution is it is bell-shaped like the normal distribution, but has heavier tails. So if we can observe, they have a similar shape, which is like a bell. But if we can observe on their tails, the t distribution is farther away from the horizontal axis. So the normal distribution is closer to the horizontal axis. So that is their difference. The third property of the t distribution is that the mean, the median, and the mode are all equal to 0, just like the normal curve. The number 4, the variance is always greater than 1. As the number of degrees of freedom increases and approaches infinity, the variance approaches 1. Variance and standard deviation are measures of how spread the data is. So it says here that if we increase the number of degrees of freedom, then the variance becomes closer to 1. It also says here that the standard deviation varies for a t distribution. For normal distribution, that standard deviation is equal to 1. Number 5, as the degrees of freedom increases, the t distribution curve looks more and more like the normal distribution, because just like what we have told here in number 4, as the number of degrees of freedom increases, the variance approaches 1. And the variance of a normal curve is also 1. So we have here an illustration. The black curve here is the normal distribution. Okay. For 1 degrees of freedom, so that is red, it is quite lower than the normal curve. If we increase the degrees of freedom to 2, so we can see here the blue curve, it is becoming closer to the normal curve. 5 is this yellowish curve. Ayan, another closer. It becomes closer. And for number 10, it almost seems like the normal distribution. So if we still increase this one, this degrees of freedom, it tends to look more and more like the normal curve. We now have here the sixth property of the t distribution. So it says here that the total area under a t distribution is 1 or 100%. So to illustrate this blue shaded part of the curve is the area. And when we add this up, this is equal to 100%, or that is 1. Okay. So accordingly, these areas also represents the probability or the percentage associated with specific sets of t values. We have here a t-table, and for us to be able to solve areas or probabilities under a t-distribution, we first need to understand this t-table. So an example is shown here, and we can see that this t-table shows the areas in the right tail only of a t-distribution. So you can also find online the areas in the left tail, or you can find the different formats of a t-distribution, of a t-table. But if you are going to compare their values, they have the same values. So in our table here, we have here the areas in the right tail shown on the first row. So 0.25, 0.20, 0.15 until 0.005, those are our areas in the right tail, because this is a right tail distribution. If this is a left tail distribution, then this will be the areas in the left tail. Next are the degrees of freedom, which are shown on the first column of our table. So we have here 1, 2, 3 until infinity. These are our degrees of freedom, which determines the exact shape of our uh, t-distribution curve. And then finally, these are values 1.00 until 3.850. These are our t values. Okay, so these are found on the horizontal axis of our t-distribution curve. To further understand this t-table, let us have here an example. We have here the degrees of freedom, which is equal to 5, and then the t-value is equal to 2.015. We are now tasked to find the area to the right. So we need to locate the 5 degrees of freedom in our t-table, which is this column. And we need to find the t-value, which is equal to 2.015. So under the column of the 5 degrees of freedom, we need to look for 2.015, which is this value, which is found in this part. We have here 2.015, and so the corresponding area to the right, or in its right tail, is 0.05. So we have here the area to the right is equal to 0.05, and then the area to the left is equal to 95%. How did we know 95%? We know that the area under a curve of a t-distribution is equal to 100%, right? So since the area to the right is 0.05, we need to subtract that from 1. So 1 minus 0.05 is equal to 0.95, or that is simply 95%. This is an illustration of this problem. We have here 2.015 along the horizontal axis, or that is the p-value. And then this black shaded part is the area to its right, which is equivalent to 0.05, or that is 5%. The area to this left, this unshaded part, this is equal to 0.95, or that is 95%. We have here more examples, and we are tasked to complete this table. So you are given here the degrees of freedom, and we are going to complete the area to the right, the area to the left, and the t-values for some parts. So to guide us, we have here a t-distribution table, or a t-table. So let us start with the degrees of freedom 10, and then the t-value is 2.228. We need to find the area to the right. So again, we need first to locate the 10 degrees of freedom, which is in this row, and then 2.228, which is the t-value. So that's 2.228, this part. And so the area to the right is 0.025. So we can write there 0.025. And then for the area to the left, we simply subtract 0.025 from 1. So we will have 0.975. Number 2, the degrees of freedom is 14, and the t-value is 1.076. So it's the same step. From the 14 degrees of freedom column, we find 1.076, which is on this area. And so the area to its right is given as 0.15. So we can write here 0.15, and the area to the left is of course 0.85 because 1 minus 0.15 is 0.85. For number 3, we are given the degrees of freedom, which is 22, and then the area to the right is 0.10. So we'll do a reverse process. We need to locate 22 degrees of freedom, which is on this part, and then we need to get 0.10 as the area. So the area is found in this. So from 22, we need to find 0.10. So we have here 0.10, and their intersection with 22 is this value. So the t value is 1.321. And the area to the left, again, 1 minus 0.10 is equal to 0.90, or that is 90%. Next, the degrees of freedom is 24, and the area to the left is 0.99. Again, this state table, which we have used from this, in this discussion, shows the area to the right. We are given here the area to the left, which is 0.99. So we need first to find the area to the right. Again, the area to the right plus the area to the left is equal to 1. And so we have here 0.01. So that 0.01 plus 0.99 is equal to 1. Since we have here the area to the right, which is 0.01, and the degrees of freedom is 24, we can now find the t value. So this is the 24 degrees of freedom, and we need to find the area, which is 0.01. So this is 0.01, and we find its intersection with the 24 degrees of freedom, which is this value, 2.492. So we have it here. Next, 27 degrees of freedom, and the area to the left is 0.995. So the same step, we need to find the area to the right, which gives us 0.005. And then, since we are given the area to the right and the degrees of freedom, we can now find the t value. So at 0.005 area, we get 27 degrees of freedom. So we have here 3.690. So we write here 3 points. Oops, that should be 3.690. 0.005. Yes, that should be 3.690. Where did I get 2.771? Sorry. Yeah, it is 2.771. Because that is 2 zeros before 5. What I focused a while ago was 3 zeros. So it's right, that is 2.771. Okay, and then finally we have your 30 as the degrees of freedom, and then the t value is equal to 1.40. So this is 30 degrees of freedom, and we need to find 1.40 on the t values. However, if we can observe here, this is 1.310, and the next t value is 1.697. So if we are simply using this t table, we do not have exact values for 1.40. So we can write here between 0.05, okay, so this is 0.05 and 0.10 as the area to the right of 30. Since we do not have the exact area to the right, then we cannot solve for the exact area to the left. Now, if you would like to use or to find the exact value for 1.40, there are available calculators which will compute the exact values. An example is this calculator from stattrek.com, wherein you can find here the exact areas to the left. Okay, so this result is the area to the left. I placed here 30 as the degrees of freedom, and then the t-score is 1.40. The t-score here is the t values which we were discussing a while ago, 1.40, and so the area to the left is 0.9141. So you can just compute that, subtract that from 1 to get the area to the right. The next topic here is identifying percentiles under a t-distribution. So a percentile is a value in a t-distribution that is less than the probability in the given percentage. So to illustrate percentile, we have here an example. Math exam results show that your score is at the 80th percentile. So what does this mean? If this is you, then you are higher than 80% of your class. Okay, so you're rank 20 to 21st, and from the highest, and then you got the higher score than 80% of your class. So the same concept applies with t-distribution. So similarly, on t-distribution, a 90th percentile is the value whose left probability is 90% and whose right is 10%. So this is an illustration. The 90th percentile is the area to the left is 90% and the area to the right is 10%. So the same concept with this situation above. Let's have an example on solving percentiles. Find the 95th percentile of a t-distribution with 6 degrees of freedom. To illustrate this one, we have here this picture. The area to the left of that value is 0.95, and then the area to the right is 0.05. So if we are using a right-tailed table, then we are going to focus on this area to the right, which is 0.05. So the area is 0.05, and the degrees of freedom is 6. So 0.05 and 6 degrees of freedom, their intersection is 1.943. And so, we can conclude here that the 95th percentile is 1.943. So at this point, this is equal to 1.943. Next, we have another problem here. Find the 5th percentile of a t-distribution with 6 degrees of freedom. So in this case, the 5th percentile is found on the left tail. Why? Because at this point, this is the 50th percentile at the middle. And so, the 5th percentile will be found on the left of this 50th percentile. So the area to the right is 0.95, and then the area to the left is 0.05. If we are going to use a right-tailed table, we cannot find 0.95 on the area. But since we have the idea already that a t-distribution curve is symmetrical, then we can say that at this value, the area to the left of this value is equal to the right of its positive counterpart. Okay, so if you're going to focus on the positive, at this point, this is still 0.05 to the right, and so that is 1.943. But since we are talking to the left tail of our distribution, then we get the negative. So that the 5th percentile of the t-distribution is negative 1.943. More examples on finding percentiles under a t-distribution. So we are going to complete this table, and we are going to be guided by this t-table on the right tail. Okay, a clue in solving the percentile, if it is on the right tail, or it is greater than the 50th percentile, then you're going to get the area to the right, okay? But if it is lower than the 50th percentile, then you're going to get the area to the left and simply get the negative value from this right tail table. So this area to the right or to the left. First, we have here 22/99th percentile. Since that is greater than 50th percentile, then we get the area to the right. So we have your 0.01. That is 1 minus 0.99. So we have the 0.01. And we simply locate. At 0.01 area and 22 degrees of freedom, we have here 2.508 at as the 99th percentile. And then number 2, 80th percentile. Again, since this is greater than the 50th percentile, or it is in the right tail of our distribution, then we simply get the area to the right. So we have here 0.20. Okay, so this 1 minus 0.80, so we have here 0.20. And then locating the value from our right tail table, 0.20, and then at 35 degrees of freedom, that is 0.852 as our 80th percentile. Number 3, degrees of freedom is 9, and we are looking for the 10th percentile. Since the 10th percentile is found on the left tail, then we get the area to the left. Okay, so that is 10%, or that is 0.10. So 0.10, and then 9 degrees of freedom. So that is 1.383. But since we are talking about the left tail, then we get negative 1.383. Same with the last item, the degrees of freedom is 14, and we are looking for the 25th percentile. So this should be 25th. We get the area to the left. Okay, so because this is lower than the 50th percentile. So the area to the left is 25%, or that is 0.25. So locating in our table, 0.25 and 14 degrees of freedom is 0.692. But since again this is on the left tail, then we get the negative value. So that is negative 0.692. Okay, so that is the end of our discussion. If you have any questions, then feel free to ask. So thank you for listening, and always enjoy learning.